Hello students, welcome to lecture number 10 of 12th Physics NCERT, chapter number 2 Electrostatic Potential and Capacitance. Topics covered in this lecture number 10 is what is capacitor, what do you mean by capacitance, and also one type of capacitor which is known as parallel plate capacitor. Capacitor is an electronic device which stores charge, is known as capacitor. Now you can see in this figure there are two conducting plates which is carrying plus Q charge and another conducting plate which is carrying minus Q charge. These both plates are connected to a battery. Now there is a dielectric material which is also known as insulating material between these two conducting plates. So we can also define capacitor to be a system of two conducting plates separated by an insulating medium is known as capacitor. There are electronic symbols to define the type of capacitor. So if your capacitor is a non-polarized capacitor, you will draw two parallel lines and you can represent it as electronic symbol of non-polarized capacitor. If your capacitor is a polarized capacitor, then you can write one straight line and another curved line, and straight line is considered to be a positive terminal. Another type of variable capacitor is you have to draw this arrow showing that or depicting that this capacitor particular is a variable type of capacitor. Now what do you understand by capacitance? If the potential difference V is the work done per unit charge in taking small test charge from conductor 2 to conductor 1 against the field, then V is proportional to Q and the ratio Q by V is constant. Now this ratio Q by V, which is constant, is known as capacitance of the capacitor. Capacitance depends on three properties of the conductors. One, shape of the conductors, size of the conductors, and separation of the system of the two conductors. SI unit of capacitance is given by farad. Its dimensional formula becomes M-1, L-2, T-4, A2. 1 farad, according to this formula, we can write it as 1 coulomb per volt. Now in practice, 1 farad is a very big unit, students. So we commonly use the practical units to be very small, that is microfarad 10 raised to minus 6, nanofarad 10 raised to minus 9, and picofarad 10 raised to minus 12. You have to understand another one type of capacitor which is known as parallel plate capacitor. As the name suggests, two parallel plates which are two thin conducting plates of a particular area A held parallel to each other with a suitable distance. Now in the diagram also you can see this particular sheets are sandwiched and dielectric material is between these two particular plates. Now this dielectric distance, the width is known as D and the area is considered to be capital A. Now we can write it, the relation between potential and the electric field, to be E is equal to sigma, which is the surface charge density, upon epsilon, is equal to V by D. And you have to remember, students, that there is vacuum between these two plates. How we have to derive the formula for capacitance? We have to take, first of all, consider the charge density to be sigma. We know that the intensity of field between two parallel plates is equal and opposite charges is sigma by epsilon 0, where epsilon 0 is the permittivity of free space. Now intensity of electric field between the plates is given by E is equal to sigma upon epsilon 0. So sigma is equal to Q by A. So E is equal to Q by epsilon 0 A. This is your equation 1. Now let the potential difference between the two plates be V. Then the electric field between the plates will be given by E is equal to V by D. Rearranging the terms, we get V is equal to ED. These two equations, if we equate and substitute the value of E, then we get V is equal to QD upon epsilon 0 A. capacitance of parallel plate capacitor is given by Q by V is equal to Q upon QD upon epsilon 0 A. So finally we derived an equation for capacitance to be C is equal to epsilon 0 A by D, where epsilon 0, you know that it is permittivity of free space and the value is 8.85 into 10 raised to minus 12 farad per meter. How, when you derive this capacitance value, what are these two terms you have to take care if you want high capacitance? First of all, your A should be very large and the plates of large area should be taken. D should be very small and the plate should be kept very close to each other. These two properties you have to take care if you are interested in getting the high capacitance value. Thank you so much, students, for listening, and we will cover the further two topics in the next lecture.